Good morning everyone. Myself Indranil Mondol, Assistant Professor in Mechanical Engineering Department. Today I am going to present an important topic, solidification of metals related to materials engineering. In this video lecture I will teach you the basics of phase diagrams, the basic terms and Gibbs phase rule. Let's start the session. One of the most important objective of engineering metallurgy is to determine properties of material. The properties of material is a function of the microstructure which depend on the overall composition and variable such as pressure and temperature. Hence, to determine the phase present in the material system, an equilibrium or phase diagram is plotted. Equilibrium diagram or phase diagram is a graphical representation of various phases present in material system at various temperature and composition point. All the phase diagrams have temperature as the ordinate y-axis and percentage composition by weight as the abscissa x-axis. Uses of equilibrium or phase diagram. The equilibrium diagram is used to obtain following information. It shows the various phases present at different composition and temperature. It indicates solid solubility of one element in other. It shows the temperature range over which solidification or liquidification of material system occurs. It indicates the temperature at which different phases start to melt. Basic terms. System. Thermodynamically, a system is an isolated body of matter which is under study. A substance or a group of substances so isolated from its surroundings that it is totally unaffected by the surroundings but changes in its overall composition. Temperature, pressure, or total volume can be allowed as per the desire of the person who investigated it. A system may contain solids, liquids, gases, or their combination. It may have metals, non-metals, separately or in combined form. Phase. A phase is a substance or a portion of matter which is homogeneous, physically distinct, and mechanically separable. Physically distinct and mechanically separable means that the phase will have a definite boundary surface. Different phases are given different names or symbols like alpha, beta, and gamma, etc. Introduction of components and phases. Components are pure metals and or compounds of which an alloy is composed. For example, in a copper zinc brass, the components are copper and zinc. It refers to a independent chemical species. The components of a system may be elements, ions, or compounds. A component can exist in many phases. Water exists as ice, liquid water, and water vapor. Carbon exists as graphite and diamond. Components. The elements or compounds that are mixed initially, aluminum and copper. Phases. A phase is a homogeneous, physically distinct and mechanically separable portion of the material with a given chemical composition and structure. Aluminum copper alloy. This is beta, lighter phase, and this is alpha, this darker phase. Equilibrium. Equilibrium in a system is the state of minimum free energy under any specified combination of overall composition, temperature, pressure, and overall volume. Once equilibrium is achieved, even a minor change in these parameters of composition, temperature, pressure, volume within the system means an increase in free energy. Degrees of freedom. It is also known as variance of system. It is defined as number of external or internal factors of the system, temperature, pressure, and concentration, that can be independently changed without altering equilibrium, that is, without causing disappearance of a phase or formation of a new phase in the system. Structural constituent. Phase distribution in a system is not necessarily uniform throughout the structure. These phases are associated in different ways to form the structure. This association of phases in a recognizably distinct fashion is referred to as structural constituent of the alloy. Single and multi-phase solids. A single crystal of a material may consist of one phase only, while polycrystalline material may be single or multi-phase depending upon the nature of individual crystals or grains present. For examples, all pure metals are single phase solids. Alloys like iron and steel, rocks, ceramics, wood, fiberglass, polymers, etc. are examples of multi-phase solids. Properties of multi-phase solids is dependent upon physical and chemical natures of phases present, amount of each phase in percentage, distribution of each phase in relation to other phases, and size of domain occupied by each phase. Alloys. Pure metals, because of their poor physical and mechanical properties, are seldom used in engineering applications. Most of useful metallic materials are combinations of metals which are called alloys. An alloy can be defined as a substance possessing metallic properties, having metallic bond and composed of two or more than two elements, out of which at least one of them is metal. Metal present in larger proportion is called base metal, while other metallic or non-metallic element is known as alloying element. Elements may combine in different ways to form alloys. These elements of alloys usually show complete solubility in liquid state. However, on cooling them to solid state, they may form mechanical mixtures or homogeneous phases. Let's discuss Gibbs phase rule. The phase rule, known as Gibbs phase rule, establishes the relationship between the number of degrees of freedom, the number of components, and the number of phases. It is expressed mathematically as follows: P plus F equal to C plus 2, where P is the number of phases, for example solid, liquid, etc. F is the number of degrees of freedom or the number of physical variables, pressure, temperature, and concentration, that can be independently changed without altering the equilibrium, that is, without causing disappearance of a phase or the formation of a new phase in the system. C is the number of components in the system. For example, Pb and Sn are the components of Pb-Sn equilibrium diagram. Provided the equilibrium between any number of phases is not influenced by gravity or electrical forces or magnetic forces or surface tension, and influenced only by the temperature, pressure, and concentration, then the number of degrees of freedom of the system is related to number of components C, and phases P can be related by the phase rule equation F equal to C minus P plus 2. In studying the chemical equilibrium, temperature and pressure are considered as external factors determining the state of the system. Therefore, in the phase rule equation, the digit 2 stands for these two variables, temperature and pressure. In applying the Gibbs phase rule to the metal systems, the pressure is considered as remaining fixed at 1 atmosphere. Thus, the effect of pressure is neglected, leaving only one variable factor, that is temperature. The phase rule equation then simplifies to F equal to C minus P plus 1. Since the degrees of freedom F cannot be less than 0, C plus 1 minus P greater than 0 or P less than C plus 1, which means the number of phases cannot exceed the number of component plus 1. Therefore, in binary system having value of C equal to 2, not more than 3 phases may be in equilibrium. Considering points x and y in this figure, it is required to determine the number of degrees of freedom using the phase rule. Point x in the region above the liquidius. So number of components C is equal to 2 since it is a binary system of alloys. Number of phases P liquid equal to 1. Applying the rule F equal to C plus 2 minus P, putting the values C equal to 2 and P equal to 1, then you will get degrees of freedom is equal to 3. Point Y, between the liquidius and solidus, number of components C equal to 2, number of phases P, that are liquid and solid, 2. Applying the rule F equal to C plus 2 minus P, putting the values of C equal to 2 and P equal to 2, you will get degrees of freedom is equal to 2. In equilibrium, all factors have definite non-zero values. Therefore, all degrees of freedom cannot be less than 0. Mathematically, if greater than 0 is equal to greater than C minus P plus 1 greater than 0 equal to greater than C plus 1 greater than P. This means that the number of phases in a system cannot exceed the number of components in a system plus 1. For a binary alloy contains two metal alloy system, number of components C equal to 2. Now if P equal to 1 is equal to greater than F equal to 2, this is called bivariant system. P equal to 2 equal to greater than F equal to 1, this is called monovariant system. And for P3 F equal to 0, this is called non-variant system. Now if F equal to 2 and F equal to 1, what happens? In case of F equal to 2, both temperature and pressure can be varied independently, and in case of F equal to 1, only one out of temperature and pressure can be varied independently. And if F equal to 0, neither temperature nor pressure can be varied independently. Gibbs free energy. Gibbs free energy for thermodynamic stability of phases describes the amount of energy that released or consumed when a phase is created from other phase. Gibbs free energy of formation delta G suffix F is relative value allows us to compare energies of different phases. So by the conversion, the value of delta GF for pure metal or element is assumed 0. The phase having lowest value of Gibbs phase energy is a stable phase. Gibbs free energy of any phase varies with the pressure and temperature. The fundamental relation between them is given as G equal to E plus PV minus Ts. P is the pressure, V is volume, T is temperature, S entropy. Delta G equal to delta E plus P delta V minus T delta S. I have told G is Gibbs phase energy in joule per mole, capital E is internal energy in joule per mole, P is the pressure in Pascal, V is volume in centimeter cube per mole, T is temperature in degree, and S is the entropy in joule per degree mole. At high temperature, phase with high entropy are very stable because Ts term in equation has negative sign. Similarly, at high pressure, phase with high volume are unstable because PV term has positive sign. The Gibbs free energy tells us whether a reaction will take place. If you want to get more videos, please like, share and subscribe my channel. Thank you.